Which filter type should you use for digital signal analysis? Imagine trying to listen to your favorite song but with a lot of background noise. Filters help clean up signals so you can hear what really matters. In digital signal analysis, choosing the right filter is like picking the perfect pair of glasses for clarity. There are two main types of digital filters: finite impulse response filters and infinite impulse response filters. Finite impulse response filters have a limited response time. They only depend on a fixed number of past input samples. This makes them stable and easy to design. They also have a special feature called linear phase response, which keeps the wave shape of signals intact. That's important in applications like audio processing or medical signals, where preserving the original signal shape matters. Finite impulse response filters usually need more calculations because they might requiring a higher filter order to get sharp cutoffs. But they are reliable and don't introduce phase distortion. On the other hand, infinite impulse response filters can last forever because their output depends on both past input and past output samples. They use feedback, which makes them more efficient and able to achieve sharper frequency separation with fewer coefficients. This means they need less processing power, which is great for real-time systems with limited resources. When it comes to the kind of filtering you need, it depends on your goal. Low-pass filters let signals below a certain frequency pass through, which is useful for removing high-frequency noise. High-pass filters do the opposite, blocking low frequencies and helping eliminate drift or interference. Bandpass filters focus on a specific range of frequencies, perfect for isolating certain signals. Bandstop filters, also called notch filters, reject a narrow band of frequencies, often used to remove power line noise. In digital signal analysis, you also need to consider how you sample the signal. The sampling rate must follow the Nyquist criterion to avoid aliasing, which can distort your data. If phase linearity is very important, like in audio or communication systems, finite impulse response filters are usually the best choice. They keep the phase of the signal consistent. But if you need quick processing and can accept some phase distortion, infinite impulse response filters are often the way to go. Design techniques like windowing for finite impulse response filters or bilinear transformation for infinite impulse response filters help customize the filters to your specific needs. So, in digital signal analysis, the best filter depends on what you want to achieve. If you need stability and phase accuracy, go with finite impulse response filters. If you want efficiency and sharp cutoffs, infinite impulse response filters are your best bet.